In this video, I'm going to be looking at set notation. This often causes a lot of trouble to students because they think, oh gosh, there's so much to remember. But I'll show you that there's actually very little that you have to remember. And once you get these key terms and what they mean, things should become a little bit more straightforward. I'm going to start with intersection, which essentially means the overlap between different sets or different groups of data. So, for example, we might have a Venn diagram, which I'll sort of show here, okay? And within that Venn diagram, the overlap would be everything that is in that section there that overlaps between the two of those. So, for example, if this section was, say, I don't know, red objects and things that could move, an example of something that could be in the middle would be, say, a red bus or something like that. Okay, so essentially what's going on here is just showing data that is just overlapped between the two of those. Okay, so that's what the intersection would be. So say, for example, we had data points where this was group A and this was B. The way we would actually write that is A intersection B. Okay, that would be the overlap between the two of those. Okay, now the next one, so that's the intersection. The next one is the union. This is all elements within a set. Within elements within a set. So all elements within a set, or all the data within a set. So let's give you an example here. Say, for example, I have a Venn diagram like this. The union, say, for example, this was A and this was B. A union B. Just like the Union Jack is the flag that shows the union of the United Kingdom, it's everything. It includes everything within there. So the union here would be everything that would be within that. Okay, so if we use the example above of red objects and that move, we might have a red rose, and a red bus would be included, and things that move as well might be cars and that kind of stuff. So essentially that is the way of looking at the union. It means all the data, and again the intersection is just the overlap of those. Now the next one here to look at is a member of. Okay, now we might use that. So for example, we could say that let's say we have a set. Let me give you an example. Say, for example, one of these here was, these could be prime numbers. Okay, so primes, and these here could be even numbers here. We could say, obviously, that there is only one prime number that's even, and that's 2, but other primes could be 3 and 5 and 7, and even numbers could be 8 and 10 here. Okay, now what we can actually do is pick individual elements or individual items within there. So we can say, look, 7, okay, so 7 is a member of primes. Okay, we could call that set P there, or you can call it just primes like that. So 7 is a member of primes. Now, how do we actually write this? Well, this set here, primes, or which we can call P, we actually use this notation with these sort of squiggly brackets like this. So the members of primes could be 2, 3, 5, and 7. These are just the ones that I've included. And this set here, which I can call E, might be the even numbers. And so even numbers that we've included would be 2, 8, and 10. Of course, there would be many more evens, but these are just the examples that I've given here. So this is just the notation of how we write it. We use the squiggly brackets to list all of the elements, and if we want to say that any particular item is an element of or within a set, we could say 5 is a member of primes, and we could say 8 is a member of even numbers here. So that is how we use this this sort of E-looking symbol, the member of. Okay, so it's contained in the set. Okay, now the next one here is this little C-looking thing, which means a subset of. Okay, now this is a little bit more complicated, and some people freak out a little bit about it, but let me take a second and show you. So say, for example, we've got a Venn diagram here. Now we can see that those two are next to each other, and that's absolutely fine. So we could, set A and set B here. But sometimes we get subsets within another set. So for example, okay, let me show you this. If we've got set here, which could be even numbers, within the set of even numbers, we might get numbers that are in the 4 times table. Okay, in the 4 times table, because as you'll recognize, if we go 2, 4, 6, 8, 10, 12, you'll see that numbers in the 4 times table will always be even. So what we could do here is we could say, let's call this set F, and I'll call this one here set E, okay, where E is evens, okay, and F is 4. We could say that F is a subset of E, okay? It's because F is within E. So this is my set F here, and it's within the E. So that's where we use this this subset, and so it's contained inside. Okay, so it just means it's contained within inside. Now, the next one here is the complement, or not in. So say, for example, we have a piece of data where we say that we want to list set A here. This would be everything within set A. Okay, so if I just have my set A, everything within set A would be here. Okay, but if I want to show that elements are not within A, I can say A not. It's kind of in the same way that someone might be say, oh, I'm going to fly to the moon tomorrow, only joking. It's almost like a sort of take back whatever you've just said. Now, that's obviously a terrible example, but this is everything not in A. So this is my A here, okay, just like we had here. Everything not in A would be everything outside of the A that's not included within that. Okay, so we can, and I'll look at some slightly more complex examples in just a second, but essentially what all that means, this little dash here just means that it's not in A. Okay, so not in A, it's not included. Now, I'm just going to skip the next one and just show you this one here. This is known as the universal set. This is everything that we will be looking at within a set, a specific example. Now, where this can sometimes come up and students can sometimes get a little bit undone is this. Say, for example, we're told that our universal set, okay, that our everything is even numbers from, say, 1 to 20. Of course, that'd be 2 to 20, but that's absolutely fine. And we're told that set A, okay, is multiples of 3. Okay, and we're told that set B is multiples of 5 here. Okay, now what can happen is people can miss this first part here. It's just saying they're even numbers from 1 to 20. So what the question might ask is, say, list the members of set A, for example, and in this case, of course, if we were doing multiples of 3, we might get 3, 6, 9, 12, 15, 18, and say 21 or something like that. Well, the problem is that, of course, we're just dealing with even numbers from 1 to 20. So in fact, that would just be the 6, the 12, and the 18. Okay, so in fact, the actual members of A, okay, so A, the actual members of A in this case would be 6, 12, and 18 in this case. So do look out for this this universal set, because it can sometimes give you questions to give you a instruction that might make the question a little bit harder or help clarify what's going on in the question. The next thing to look at is the one I skipped, the number of elements within a set. So say, for example, we have our set A is 2, 5, 8, 10, and 12. Okay, well, the number of elements in A would be 1, 2, 3, 4, 5. So it would be 5. So essentially, this is just a notation that says how many elements are in that particular set. Now, an extension of this is the notation that uses the P here. And what this means is probability, okay? That's the probability. So what you might find is if you've got a Venn diagram here, okay, and we say that there are 5 elements in A, and 3 in the overlap here, and 4 within B. What the question might ask you is, what is the probability of picking something from A? In this case, everything that is in A is the 5 plus the 3, okay, so that's 5 plus the 3, which we know will give us 8, but that is because it's a probability, it is out of the total. Now imagine there were 2 outside here that weren't in either A or B. In total, we've got 5 plus 3, which is 8, plus 4 is 12, plus another 2 is 14. Okay, so the total is out of 14. So the probability would be 8 out of 14. Of course, we can simplify that to 4 out of 7. But this is a probability. Now, what we might then get is a question that asks us for the probability of A intersection B. Okay, now remember back to what we were talking about. Intersection is the overlap between A and B. So that is only that 3 there. So that would be 3 out of the total of 14 here. So again, please be careful of these, this probability and also the number of elements within there. So probability would always be out of the total, and the number of elements here. So if I was asked for the number of elements of A intersection B, that would just be how many are there in the overlap, and the answer there would be 3 there. So we've looked at the notation, okay, these little symbols. Now, once you get your head round using these, the questions can then become a lot more straightforward. But of course, let's look at some tougher questions. So here we go. Now we're going to use some combinations. Now, say, for example, I've got a Venn diagram here. Now, we've looked at what happens when we see the overlap of the 2 of those. But let's look at the complement, which can make things a little bit more difficult. Now, say, for example, this is my set A and this is my set B here. If we're looking at the overlap between the 2 of them, that would be this section here. So this section here would be A intersection B. But if we were asked to list the elements of A intersection B, and they put that in brackets and put not, okay, that's the complement, what we would then do is we'd have to draw our Venn diagram here. This is our A and our B. It would be everything, okay, everything that is not in that overlap there. Okay, so remember, the overlap is everything in the central part, so everything that is not in there, okay, would be everything round the outside of this little section here. Okay, now what could also happen is we can get questions that become a little bit more complicated. So say, for example, we have a Venn diagram here, and this is my A and this is my B here. If we were asked to find the elements that were in A naught intersection with those in B, what we do is we break it down. Okay, we're going to do them separately. So I'm going to list all the elements that would be in A naught. Okay, so A naught would be everything that is outside here. Okay, everything that is not in A. Okay, because we're using this complement sign. So it's everything that's not in A, and I've done that in red here. Now I'm going to shade in everything that is in B in blue here. So this is everything that is in B is blue there. Now, one of the questions might ask us to find a union that, which means it would be anything that was shaded in. But what we're being asked here is we're being asked for the intersection, okay, or the overlap of those 2. So i.e., it's only the place where we've got the double shading, i.e. we've got the double area. So that would be just this section here. That's the section where we've got both blue and red. Okay, that's where we've got blue and red. Now, say, for example, here we go, I'll give you the same question here. Not drawn amazingly well, but let's have a look. Say we were asked for A naught unioned with B. Okay, now remember, union means everything. Okay, so it's inclusive. So essentially what's going to happen here is we're going to do anything that has any form of shading at all. So again, A naught, I'm going to do this is everything that's not in the A here. So let me just shade in around the outside here. Okay, take a little bit of time to do this. That's everything that is not in A. We can see that that's our A and it is absolutely not shaded in. Okay, now what I'm going to do is shade everything in blue that's in B. Okay, so this is everything here that is in B. Now, because we're inclusive, we're including anything with any shading. So what we say, when we use this U symbol, union, it's all of the stuff that's not in A and all of the stuff that's not in B. And we're going to include all of it. So instead of just being this overlap part, it's anything with any shading at all, which is anything with red and anything with blue. Okay, so it's anything with any shading at all. Okay, so hopefully you can see that the only section that doesn't have any shading would be this one here. Okay, but everything else is fair game. Okay, so that's essentially how it would look. You just shade in all of this. Okay, so it's anything that had any shading at all, and the bit that you leave empty is that middle part. Okay, whereas with this one, the only thing that we've included is where there's the double overlap, so it is this section here. Okay, and if you want to see it more simply, just so it's a little bit more clearly, is it's just this section here. Okay, whereas for this one, it is everything is shaded in. Okay, so everything is shaded in apart from this little section here, so it's everything around there. Okay, has been shaded in. Okay, and obviously you can do it a little bit more neatly than me, but essentially it's that. Okay, now I just want to show you one last thing. Say, for example, we're asked to find A intersection B not. Okay, now what actually happens, similar to kind of a minus, what actually happens here is if you do a not to the whole thing, it turns out it's actually the same as if you not the A and not the B, and flip that N to become a U, okay, or flip that symbol to become a U. Those are actually the same as each other. Now let's look at this first one. What we're saying here is that A, okay, intersection B, of course, would just be this middle section between the two, the overlap of the two. But everything that's not in that, okay, so everything that's not within that would be everything round the outside. It doesn't include this little middle part here. Okay, so let me just shade that in, and it's not massively neat, but it gives you an idea that it is everything outside of this overlap, because what we're saying is A intersection B, of course, would be that middle part there, and not in that is everything on the outside. But let's have a look at what's going on here. Right, so we're doing everything that's not in A. So what I'll do is I'll just draw that white around the outside, and let's do this. Now, everything that's not in A, I'm going to do in blue. Okay, so this is everything that is not in A here. Okay, that's everything that's not in A. You can see I've avoided going into the center of A. Now in in red, I'm going to do the B. Okay, so everything that's not in B. So I'm going to just basically, here's my B here. Okay, and I'm not going to go into it. I'm just going to do everything round the outside of the B here. Okay, so that's everything outside the B. Now, what we're doing is we're saying union, which means anything with any shading at all. Okay, so anything that has any shading at all, I'll just basically colour in everything that has any form of shading at all. Okay, and hopefully you can see when I make it sort of white that actually the only place that doesn't get coloured in is that centre part. So those are actually the same. So here's the trick again. Essentially, if you take A intersection B, and you do not, what will happen is that A becomes not, and the B becomes not, or complement, and the little symbol in the middle will flip over. Okay, so say for example we had A not unioned with B, okay, and then we do a not on the outside. What will then happen is we're essentially going to do the opposite of each. So that becomes A, and instead of becoming not, it just becomes normal. Okay, so it switches. All right, the B will become not because so that switches to. Okay, and the union will then flip to become intersection. Okay, so those are the same as each other, and that's a little trick just in case you get much harder questions. Now, to recap, and we look at everything we've done. We've looked at the set notation and how each of those symbols represents either both data, so elements, and also how they're used in Venn diagrams. Take a little bit of time just to get familiar with each of those, and then have a look at some questions, and hopefully this should make things much clearer.